All right, welcome everyone. In this webinar, we'll cover open source notebooks in Cassandra, the main topic of doing SQL on Cassandra from within these notebooks. We'll have a little demo later on in the webinar showcasing two of the notebooks that we discuss. And then a little about me. I'm an apprentice here at Anant. I've been here since December 2019. This webinar specifically is part 3 in our doing SQL and reporting on Apache Cassandra with the open source tools. Part 1 was using Presto and doing SQL and Cassandra, and part 2 was using Spark and doing SQL and Cassandra. These are linked here. They have written walkthroughs as well as introductions of the demos that we did for those webinars. But the webinars for those two parts as well are linked in those blogs themselves, or you can watch them, the webinars themselves, at youtube.com/AnantCorp. So in this webinar, we're going to focus on four main open source notebooks. The first one, Jupyter Notebook, pretty synonymous in the data science world. Apache Zeppelin, another open source notebook. Quix notebook, if you've never heard of it, it's relatively new. It's by Wix, W-I-X, and Polynote, which is another open source notebook. So starting with Jupyter Notebook, it's a web app that allows you to create, share documents that contain live code, equations, visualizations, and narrative text. The main use cases for using Jupyter Notebook are for data cleaning, transformation, numerical simulation, statistical modeling, data visualization, machine learning, and much more. A little on the machine learning using Jupyter Notebook. One of our team members, Obi, he has a series using Spark and Cassandra and doing machine learning on top of it within Jupyter Notebook. So if you want to follow along with that series, he just wrapped up part 5 yesterday. And it's available on youtube.com/AnantCorp, or you can go to our blog site, blog.anant.us, and search for Spark and Cassandra and machine learning, and you can find the accompanying blogs with those. So Jupyter Notebook supports over 40 programming languages. You can see to the right all the different technologies you can use with Jupyter. Notebooks can be shared using email, Dropbox, GitHub, and their internal Jupyter Notebook viewer, which you can access through their site. We'll be using GitHub. I've already uploaded the repo, or at least the notebook that we'll be using, on a repo on GitHub. It will be linked in this slide deck. And Jupyter Notebook, it could produce rich interactive output, HTML, images, videos, latex, and custom MIME types. And a big, as mentioned before in the use cases, you can leverage big data tools like Spark to do machine learning, data cleaning, transformation, and eventually visualization with other technologies such as Pandas, which is data analysis and manipulation tool, TensorFlow, which is a big machine learning program. So a little bit more about the Jupyter Notebook itself. Here's an example one to the right. It's an open document format based on JSON, and then they contain a complete record of the user's sessions, including code, narrative text, equations, and rich output. The notebook itself communicates with computational kernels using interactive computing protocol, and an open network based on JSON data sent over ZMQ, which is kind of a messaging tool, and WebSockets. Kernels themselves are processes that run interactive code in a particular programming languages and return the output to the user. Kernels also have tag completion and introspection requests, which we might take a look at in the demo. So the next one is Apache Zeppelin, which is also another big one. And it also allows data-driven interactive data analytics and collaborative documents with SQL, Scala, and more. It supports Spark, PySpark, which we'll be using in the Jupyter demo, Spark R, Spark SQL with their dependency loader. Their interpreter allows multi-language data processing, and you can currently use Spark, Python, and then through their JDBC, you can access all kinds of other databases. And main use cases for Zeppelin: data ingestion, data discovery, analytics, visualization, and collaboration. A little bit more on the collaboration in the next slide. So their notebooks can be shared as an embedded iframe, which is pretty cool. So say if you want to put it in a dashboard, if you want to put it on a website, and then you can also share the URL so that they can be collaborated and the changes would be made in real time, kind of how like Google works, Google Docs, Google Slides, etc. And the visualizations themselves, a little example to the right, they're not limited to Spark SQL queries, as any language used in the backend can be recognized and visualized. And then the third one, Quix. So Quix, as I mentioned before, by Wix, it's going to be the other notebook we'll demo. So we're going to be demoing Jupyter and Quix. And the reason for doing this is we're going to be using Presto with Quix, as Presto is supported in Quix itself, in addition to Athena, BigQuery, MySQL, Postgres, and others through JDBC. And Quix utilizes Presto, and through Presto you can access even more. So it allows for multiple data sources, and it could be a shared space for BI insights, and we'll go a little bit more into that in the next bullet. But if you look to the right, it's a little GIF of how dashboard looks on Quix, and then on the left they're using their database explorer, which you can essentially look through all the databases you have access to and look at the schemas. You can run temp queries and get your data back. And so going back to how it's a collaborative tool, you can run Quix in a single user or multi-user auth or mode using Google Auth. And that is something that you can just mess with in the env file. And we'll go over that when we get to the demo. As mentioned, the DB Explorer, you can navigate, search, and preview your tables. And a nice thing about Quix that I really liked is that they have one-click visualizations. So when you run your queries, when you see, if you look at the GIF right here, it has the tabular view, and then there's a little line icon. So when you click that line icon, it's a one-click visualization. So their smart chart will take your data and then build a graph for you that you can further edit, which we'll also take a look at in the demo. And then again, in the same sense that it's a collaborative tool. So Wix uses Quix internally. And so if you're using multi-user mode, you can search queries that have been made across all kinds of users. And the last notebook that we're going to talk about is Polynote. And Polynote's an experimental polyglot notebook. We'll talk about what polyglot means in the sense of this notebook in the next bullet. Currently, it supports Scala and Python with or without Spark, SQL and Vega, and we'll talk a little bit more about Vega in the next slide. So polyglot, meaning it's multilingual. And it's a quick definition of what polyglot means. And so what that applies to in Polynote is that it supports mixing multiple languages within a single notebook. And you can share that data between them seamlessly. You can access those variables and store them in access. So say if you have one variable that got data back from something written in Scala, you can access that variable in something that you're running with Python. And a couple of unique features of Polynote are interactive autocomplete. They highlight your errors, rich text editing, latex equations if you want to build them, individual task tracking so you can see what's being run at the specific time, ordered cell semantics so it'll run top down, and it'll highlight the running statement in real time. So if you look to the right, if you can see it well enough, but if you go to their website, you can see it better. So they're essentially running a wine data analysis that they'll be using Spark. As you can see, they're reading their data, and then they're going to use their visualization to see it. And also another cool thing about Polynote is that it has a symbol table that you can keep track of. So if you lose a little bit in the sense of you have a pretty big notebook and you're trying to figure out what variable you need, they have a symbol table that you can track, and you can see what's in that cell, and you can highlight it and see more detailed information about that variable. All right, a little bit more about Polynote. It has first-class integration with Apache Spark. So as mentioned in the little GIF on the right, it's using Spark in the notebook. You can browse table structured data based on their data structures or your Spark data sets. And you can see rich representations of your data automatically derived or supplied by a type class. You can see a little bit more about that in their on their website. And then going back to what we talked about in the first slide, you can easily create visualizations with their built-in plot editor, what they're doing in the GIF, or you can use Vega, which is a visualization language, and it's pretty cool if you take a look at it. All right, we'll stop for questions here, see if anyone has anything. Nope. All right, so we're going to move on to the demo. We're going to be using DataStax Enterprise for our Cassandra, just what I already have locally. And we're going to be using DataStax Studio for a notebook that we're going to be running our CQL commands in. And you can find that linked in that list. As mentioned before, we're going to be using Quix because we can use Presto with it, which we've done in part 1 of this series. And we're going to be using Spark / specifically PySpark with Jupyter that we did in part 2 of this series. And we have some additional resources once the slide deck is available tomorrow when this YouTube video goes up. And we have additional materials with the GitHub, and that has the Jupyter Notebook as well as additional materials available to you. So starting with the demo, we're going to start with Quix. But before we start with Quix, we're going to download our notebook for our DataStax Studio notebook. All right, and then we're going to open a terminal. And in this terminal, we're just going to cd DSC to get our Cassandra server running. While that loads, we're going to cd into our DataStax Studio directory, and then we're going to do bin server.sh. If you've been to part 1 and part 2 of these series, you're already familiar with these commands. So while that runs, we're just going to double check and make sure our Cassandra server ran. It did. And then we'll just give a second for the DataStax Studio to run, and then that's going to point to localhost 9091. It should be up soon. All right, so while we wait for that, we're going to take a look at Quix real quick. So getting Quix started with Quix is pretty simple, and they give you 4 commands to run. So you'll need Docker for it. And this env file, when you run it, you can edit it. So we'll be using Presto. So if you look in their documentation, they can show you what you need to have in that env file. And if you make changes within your env between sessions of Quix, you can just quickly run Docker compose up and then with the flag D so that the environment gets reset with the new env file. So if we go into Studio, what I like about Studio, you can drag and drop this notebook. And I've already set this demo up for you. Again, like I mentioned, if you've been here for the past 2 parts of this webinar, you're already familiar with this notebook and what we're trying to do with it. And in order to make this demo as streamlined as possible, we're just going to run this notebook first and then do our SQL with our other 2 notebooks because I've already showed you how this works. And if you're not familiar, you can go back and watch the videos. They'll be linked in this YouTube description when it goes up. So essentially the setup of this notebook is we're going to create a key space in CQL, and we're going to create 2 tables. So this first table is going to be spacecraft journey catalog. We're going to seed it with 1,000 records, and then we're going to just verify our data is there. And then we're going to create a second table, which is spacecraft speed over time. And this data model is obviously, it's strictly for demo purposes and what we're trying to show we can do with the tools we're using. So take these data models with a grain of salt. So we're going to create the second table, which has spacecraft speeds over time. And then we're going to seed that second table. And then we're just going to verify we have data in there. And then the last reason is why we're looking at tools we can do SQL and Cassandra. CQL natively cannot do joins, right? And so what we're trying to do is per spacecraft from the first table, we want to get the spacecraft's name, we want to get the summary of that spacecraft's journey, and then we want to get the speed of that spacecraft based on journey. So we're just going to do an inner join based on journey ID, which is linked in both tables. In just native CQL can't do that join statement, so we'd probably need to run 2 queries and then figure out a way to put it together. Or you could use within DataStax Studio, you can run Spark SQL, but we're just going to be running PySpark and Jupyter. But yeah, let's go ahead and get started. So we're going to go ahead and create our key space. We're just going to run local quorum. It's going to get created. And then we're going to create the first table. So when we create the table, we need to make sure we select demo as our key space, and we're going to run it. All right, data success. Here we're going to seed 1,000 tables into demo, and we're going to run that. Just give it a second. It's 1,000 records. And then we're just going to verify the first table got seeded. And it did. So again, like I've mentioned in the past 2 webinars, if you don't want to use DataStax Studio, you can still download the notebook file from Google Drive. And you can, once extracted, you can use the code.txt file. And I'll show you what that looks like. Let's extract that real quick. So when you open this code.txt file, it's essentially this notebook and just text. So if you just want to take these CQL commands and run it in your local Apache Cassandra instance running CQLSH or any kind of variant or distribution you're using, you can. But again, just because we're seeding 1,000 records, it's chunky, so it's just easier to do it this way. All right. So now we verified that there's data in the first table. We'll go ahead and make the second table. Remember to select demo as your key space. We're going to seed the second table. All right, success. And then we're going to just confirm our data is there. So we're just going to do a run as select all. Great. We have 18 records is what we added here. So now if we try running a join statement in CQL, so we're going to run our demo, and that won't work, right? There's no viable alternative input for enter. So now this is going to get into our series doing SQL and reporting on Apache Cassandra using open source tools. So the first open source tool we're going to look at is Quix. So I have already installed it. So I've already run these commands. And one thing to note in this env file, if this API doesn't work for you, I'll show you what mine looks like. So mine, let's go to the Docker, nope, the env file. So mine is host Docker internal. So depending on your OS, it might change. So if you're running a Windows, this might work for you, but I'm running Mac. So if you're using Unix or Unix-like, you might need to use the local Docker one that I have, and you can just Google that. It's mentioned in their issues on their GitHub. So let's go ahead and start running that. But before we do that, we also need to run our Presto server. So if you were here for part 1 of this series, Presto and Cassandra, we go over installing Cassandra and getting it running and doing a demo with it. So we won't be using Presto's CLI. Quix will act as the CLI. So I'll show you what that means later. But right now, we're just going to cd into our Presto server directory. And there's 2 ways of starting Presto. There's one starting it with the logs and one without. We're just going to do it without the logs, just so it's not showing up on the screen the whole time. So we're just going to, for me, I have to run sudo. It might depend on your operating system, but for us, it's just sudo. So sudo launcher start is without logs, and that's what we'll be running. And run, sudo bin launcher run is running it with logs. So now we have our Presto server running. So we can go to localhost 8080, sorry. There's so many localhost ports. Yeah, so localhost. So our uptime with our Presto cluster, 12 seconds. So we just started it. We have 1 active worker. Just so you just don't get confused, we're going to click this finished tab so we can see all the queries are running from within Quix. All right, so Quix is going to be run at localhost 3000. So if we go back to our terminal, open a new tab, cd into Quix, and before we do that, we just need to run Docker Let's give that a second to start. All right. Let's see, what can we go over while we wait for that? I think pretty much good. So let's go back to our terminal. Let's run docker compose up. And just to make sure, if we have environment changes, I'm just going to run it with the flag D just in case, just so that it's fresh. And then we should see a bunch of logs start showing. There. So we have our Quix up. So if we go into our database explorer, just give it a second to load. And if the dropdown doesn't show right away, just refresh it and it should show up. So this Cassandra, that's coming from the catalog. So if you're not familiar with the Presto catalog is, you can refer back to our first webinar, Presto and Cassandra. You can find that on youtube.com/AnantCorp. And we go over what the catalog is and what's the purpose of it, how to set it up. And so essentially what it is just saying, this is our connection. And so we're in the catalog, we say connect to 127.0.0.1, which is our local instance. And see, we have our demo schema in SQL terms, but our key space. And if we click it, we can see our two tables that we made. And if we click on it, we can see the kinds of columns we have and our types. So if we just click on it, see, we select rows 1000, this one's 18. So we can just run this temp query and we see it, right? And so like I mentioned, we have one-click visualization. So if we click on chart, we see a chart of our data, like Quix's smart charts. But let's go into our notebook. So we have a folder structure, which Quix provides, which is nice. But we have this new notebook that we'll be using. And if it's not already using demo, you can just say use demo. And it's going to come back result true. And if we go into our Presto UI, we can see these queries that we're making from Quix itself. So like I mentioned, we're not using Presto CLI like we did in part 1. We're using Quix as our CLI. All right. So now that we've said use demo, we're going to make some queries. So we're just going to see that our tables are there. Sorry for my puppy sees a friend outside the window. All right, so we're just going to run show tables, and we see our two tables in there. And we're just going to just double check. We're going to run that same CQL statement we ran in our studio. So this very first one, scroll down. So this select all from the first table and select where the name equals Vostok1, and we get back our data. It matches. So now we're just going to run the second selection where we check the second table was created, and we see it. And you might notice that some have the quick chart, some don't, and that's probably because this one has a number component to it, which makes it chartable. And so now we're going to try running this join statement that didn't work in CQL and try running that with SQL and Presto. So if we run that in our notebook here, we're going to get back or return what we were looking for. So we were looking for a spacecraft name from the first table, the summary of that spacecraft's journey from the first table, and then the speed of that spacecraft based on journey ID from the second table. So we have now been able to run a SQL join statement on a NoSQL table using an open source notebook like Quix, using Presto specifically. So if we go into our chart, like I mentioned before, we can customize it. So right now, what it's doing is it's taking, there's 2 speeds per spacecraft is the way I made the demo data. And what it's doing is it's combining them. So we can just change this group by. So say let's group by speed, right? So now we can see for DataStax 33, one flight, it has 2 flight speeds. It has 3077K and 3076K. And you can see that for each flight in this quick data visualization, which makes it very easy and fast, which you can then share. Again, this is local, but you can share the URL through the clipboard with if you're using a multi-user space, but we're not. And then you can also add notebooks to favorite, which is pretty cool. And again, if you have multi-users, you can have a user list that you can eventually further search. And also a nice thing is they have a playground that you can use and just build CQL or SQL statements on. And then you can add custom parameters to use variables, etc. All right, that covers Quix, our first open source notebook. So now we're just gonna kill it. So we're just gonna Control C. All right, didn't work, so we're just gonna do copper docker compose down, and that's gonna stop it. So let's just close out of this terminal. We can stop our Presto server because we're going to be moving on to Spark with Jupyter. We're just going to run sudo bin launcher stop. All right. So before we move on to Jupyter, it looks like we may have a question. So let's check. Are these notebooks used for high volume or concurrent? Is that supposed to be of or of concurrent queries? Let's see. I believe based on what Wix had documented for the Quix documentation, they use it for high volume Presto and parallel queries for internal BI, if that answers your question. But I believe so, depending on what technology you're using. So we're using Presto specifically, but if you're using JDBC and accessing something different, it might change. But Presto is, by technology, it's a distributed SQL query engine for big data. So I'd assume that this notebook, specifically Quix and most likely Jupyter, would be able to account for high volume of concurrent queries. All right, so we can go ahead and just make sure this is dead, and it is. Let's go ahead and quit Docker, just so it doesn't take up CPU. And so now we're gonna move on to Jupyter. Jupyter, it's pretty simple to install. For Mac, you just pip install. We're gonna be using this GitHub repo. Like I mentioned, it already has our Jupyter Notebook, which I've already loaded for you. And we're just going to clone it down, but we're just going to download it as a zip for now. So you download as a zip, and extract it. All right, just give that a second. Don't want that. Let's go to our terminal. And we're, oh, nope, that's not what I want. I want to run Jupyter Notebook. Now it's going to load our Jupyter Notebook. All right, and then we are going to upload the item we extracted from our downloads. See, which one is it? It is this one, Notebooks Master 2. All right, we'll just upload this notebook, and then we'll go ahead and start it. Great. So with this notebook, we're going to be using Spark to do SQL and Cassandra, specifically PySpark. So there's two ways of starting Jupyter with Spark. We'll be doing it, you can Google it, but we're just going to be doing it within the notebook itself versus exporting path variables within your terminal and starting it there. But essentially what we're going to do is we're going to take our PySpark submit args, and we're going to use DataSpec's Spark Cassandra connector, and we're going to set our Spark Cassandra connection in the config file that goes with that connector at 127.0.0.1, which is our local, and we're going to use it in PySpark. So this first one, we're just going to go ahead and run. I'll have this terminal up just so you can see what's happening. So we'll click run. Nothing's going to happen running this first terminal, but when we run this second when we run the second cell, we're importing Spark context, Spark session, and SQL context. And we're going to be using Spark, which is loaded with the Spark session and the local instance of Spark context. And we're going to be using Spark.SQL to run a SQL query, like legitimate, like a straight SQL query versus using data frame API when we're running the actual query itself. But we'll go ahead and run the second cell, which you'll see it essentially accessing the Spark Cassandra connector, etc. So what this third cell is doing, it's going to take our data in our Cassandra. It's going to format and take our table name and key space name and then load it as a data frame. So when we're going to run this third cell. Don't want to get ahead of myself. This data is already here, but that's not the important thing, but we just know it works. So what's going to happen is when we run this function to load this variable as a data frame, we can show it like so, and that's going to bring out an output like this. So it's only going to show the top 20, because remember, the first table, Journey Catalog, has 1,000 records, but the data's there. But the important thing here is when we do a .create temp view, or you can do it with create or replace temp view. So what this does is it registers that data frame we made with the function as a SQL temporary view that we can access with the SQL function from Spark session. So remember, we set Spark session as Spark here, Spark session, and we're going to be accessing the SQL function. So if you try running this by itself, so if we use this variable in the statement, SQL statement that we make in this one here, it won't work because we haven't registered it as a SQL view. So this is going to do that, and we run that. Let's give it a second. It should load. See if anything comes up in terminal. Nope. All right. No errors. So now we're going to, oh, sorry, I went ahead of, so we just ran this one. Now we're going to run this one, which is essentially the second table, spacecraft speed over time. We're going to do the same thing. We're going to take the table, and then from key space demo, we're going to load it as a data frame. We're going to show it, which is going to get these 18 records from the second table. And then we're going to create a temporary SQL view. And we're going to run that. And we have it come up. So now we get to our same state, the join statement that we've been trying to run SQL on, but we can't. So if you watched part 2 of our of this series where we looked at Spark and Cassandra, you'll see a similar, like I mentioned, the SQL function. So instead of using the data frame API, we're going to be using this. And so we just copy and paste our SQL statement. But again, like I mentioned, if we don't have that create temporary view, we can't access these variables like so. So if we tried using just this here, it won't work. And so that's why we need to use these create temp views or create or replace views. And so when we run this join statement and have it appended with the .show function, we're going to get back the same thing we got back in our Quix. So if we run that, oh, what just happened? There we go. Now it came back. So we got our spacecraft name from the first table, the summary of that spacecraft's journey, and then we got the speed of that spacecraft's journey based on journey ID. So we've used Presto with Quix, we used PySpark specifically, but Spark with Jupyter. And we've shown that you can run SQL and join statements on Cassandra using notebooks, using Presto CLI, using Spark Shell from part 2, and Presto CLI from Spark part 1. But yeah, so with open source tools, we can do SQL and reporting on Apache Cassandra. And that will wrap up our demo. And let's see if we have any questions that came in. None. So if you liked what you saw and you want to reach out to us here at Anant, we work with scalable fast data, main technologies, Cassandra, Spark, and Kafka. We work with different programming languages. And if you need to reach out to us, you can reach out to us at anant.us, or you can email us at solutions@anant.us, or call us at the number listed. I hope you were able to take something away from this. Thank you for joining us. And if you have any questions, you can direct them to the chat and see if I can answer them. All right, looks like there's no questions. We'll wrap it up here. Thank you again for joining us here for Open Source Notebooks and